So let's start recording this. Yeah, there are two type of partitions. One is a static partition, other one is dynamic partition. In the static partition, you have to define everything with a hard-coded value. Which partition you are going to put the data? Which partition you are putting the data? Data are you putting into India country, India partition? Are you putting into UK or US? Which partition you are loading the data or you are inserting the data? You have to specify. If it is a static partition, in the static partition, the limitation is static partition. The limitation, the problem is you have to write so many insert statements or load statements. If you have so many partitions, let's assume that you have so many partitions, then what you need to do? You have to write so many insert or load commands we have to write, right? So to avoid that, so there is something called dynamic partition. What dynamic partition will do? So the dynamic partition, instead of you hard code the partitions, instead of you telling that you go and store here, you directly fetch the data from some staging table. Let me share. Fetch the data directly from the one staging table, and the partitions will be created dynamically. How it will be created dynamically? Because the data, whatever the data, I need to create a partitions. That data first I will load in some temporary table or stage table, whatever you call. From the stage table, I will write insert statement saying that insert into this table. Partition is this. Partition, you just need to specify the partition column. And select from other table. So you are not going to specify anything hard coded here. So directly it will fetch all the respective partitions into directly into your partition column. So how many partitions are there? It will create those many partitions. So that's what we have seen yesterday, and we had a discussion also. We had some doubt and we have cleared about it. Correct? Not only single partition, guys, you can also create multiple partition here. And you want to create country. In that country you want to create a state. In that state you want to create city. We can create those many partitions. That's called multi-level partitioning. Is this clear to everyone till here? Because the partitions, external tables, joins, these are really important. Those are really important. In the real time we'll be using them. Tell me, guys, is that clear?
One question, on this dynamic partition. Okay. Yeah, as we are loading the data into temp table and we are creating and we are actually loading into table, right?
Correct.
For the dynamic.
Correct.
Which will automatically creating all the partitioning. But as the data grows, right? Suppose the source of the data is something else which will be feeding in further. So how we will handle that kind of scenario?
The source, I didn't get the source in the sense.
The actual data file content is growing.
Okay. You're telling that automatically.
Yes. There is a source of data which is getting increased, right? Suppose we are getting the data from the sensor example.
Okay.
We keep getting the data, we keep appending that data. But we are creating this as a one-time activity, or we will keep doing that every day or something, partitioning into this table for this. I mean, how does that work in the real time? Just I'm trying to understand.
Okay, in this case, if your table is keep growing, your stage table or something is keep growing, so you have to execute this multiple times. It will not execute automatically. I mean, multiple times, you have to schedule it. So whenever,
sorry, a job, you mean to say? We need to schedule a job kind of
yes,
thing.
yes. Yeah. So any other doubts, guys? See here in the I have already shared this document. I have shared all this document. In this document, you have multiple examples. So in the GitHub, I didn't share the as a text file. I did it purposely. So I didn't share as a text file. I shared it as a PDF file. Why? Because if I share it as a text file, uh, what is no human mentality like? So we'll try to look for the easiest way. Like I will copy and paste, and we'll start executing the queries. So if we copy paste, we will miss the small things. We'll miss small things like sometimes defining partition, sometimes bit defining some small mistakes we may commit. We may forget because we assume that we know it. Okay, so that's I don't want my student to do that. So they have to type in each and every command and execute it. So that's the reason I kept in the PDF file. If you want, you guys can type in the text file, then you can execute into the terminal. Okay, so please do that. So let's continue today, and we will check is there any problems with existing with the dynamic partitions. We'll see is there any problem with the dynamic partition. Then we will move to the next topic. Okay, as we discussed before, there are two type of dynamic partitions. One is the strict mode, another one is a non-strict mode. So what is a strict mode, what is a non-strict mode? So non-strict mode means based on your data, it will automatically create any number of partitions, based on your data. So that may leads you to create so many partitions. If you keep it as a strict mode, what you need to do from your side, if what you need to do from your side, you need to sys- while inserting the data into stage or inserting table, you have to specify you have to specify the top level parent partition should be hard coded. You have to you have to specify parent you have to specify the parent has to be hard coded. At least the parent has to be hard coded if it is a not a strict mode. If it is a strict mode, at least why we are saying the strict mode, because so let's assume that I have something called country wise, state wise, and city wise. So I don't want to end up with creating so many partitions. I don't want to end up with creating so many partitions. What I will do, what I will do, I will simply write it such a way that in the strict mode, I will specify where my dynamic partition should go into specific country. So one country we will be hard coding that. Okay, you can have a reference document. Please have a reference document, not on the PDF. So you have the documents in your uh, that our drive as well. So you can have a reference of that. Okay. In that, in the partitions, you have something called show partitions. It will show all the partitions, how many partitions are there. You can also have the specific country, specific folder wise. You can see that. Suppose the parent is US, and you want to see how many sub folders are there in it. So you can also use the show partitions for the seeing all the partitions. And you have something called describe formatted. When describe the partitions, you can describe all the partition. You can see the partition, description of the partition. You can alter the partition, you can change the location, you can alter the partition which is existing, you can alter the partition which is existing, you can create and you can add a new one, or you can create, you can change the location, right? You can drop it, right? You can also drop it. So we have all these options are available for the each and every partition here. This is here, if you see, we are changing the location. So alter partition name, and this what is the location I need to refer. Okay, you can change the partition location. You can drop the partitions. Okay, you can drop the partition. You can archive the partition. All these options are available, so you guys can have look, and you guys can do it. Execute those commands. Is this clear till here? whatever we discussed. Okay, this is what we are discussing last couple of 1 week about the partition. Okay, so let's have discussion about bucketing. What is the limitation we saw with partitioning? The limitation what we have seen with the partition, we will end up with writing so many we will end up with writing so many partitions. So creating so many partitions. If you create so many partitions, that is a burden on name node. Correct? If we end up with writing so many partitions, we will create a burden on name node. Correct? Yes or no, guys?
Yes, Ravi.
Yes.
Okay. First limitation is if we create so many partitions, is burden on name node, overhead on name node. So overhead on name node. The second partition is whatever the partition we are doing, it is not equally distributed into partition. It is not equally distributed into the data. Let's say I have 100% data. Let's assume that I have 100%. The whole data is 100%, or you can treat it as a 100 MB or 100 GB. Okay. So I'm creating 5 partitions. Is there any guarantee that each partition will get 20 MB of data or 20% of the data? I mean, not all actually equally partitioned, but is there any guarantee that the data can be distributed at least equally, in the sense, not I'm not expecting exactly, but coming, so some directories are coming 2020, some directories are coming 19, close to equally distribution. Is there any guarantee that is equally distributing? There is no guarantee like that, right? So even yesterday we have created dynamic partition. If you see that, if you see that, what is the default location, guys? What is the default location of our Hive? User Hive warehouse. In that warehouse, whatever your test was is a testing, and we have created dynamic partition. If you look at here, so there are multiple partitions, correct? So this partition has almost 72 KB of data. Okay, I'm just showing you an example. Okay, it's not all the case. So this is has only 583 bytes of data, and this is has 800 bytes of data. Is there, see, where is the 500 bytes and where is the KBs of data? There is a huge difference, right? What does it mean? It is not equally distributing, right? It's not actually equally distributing the data. What does it mean? So when you have a data in 100%, few partitions are occupying few partitions are occupying 70% of, let's assume that 70% of the data. Let's assume that 3 partitions are occupying this, and the rest of the 2 partitions are occupying 30% of the data. 30% of the data. In this case, when I launch some job, so first 70% of the data will take so much of time to process than other 2 partitions. Let's assume that here I have executed group by command. Let's assume that I have executed group by command. So when I execute the group by command, again it has to scan these five partitions. It has to partition or it has to scan all the five partitions. It may be giving you a better performance when you're doing a where clause and specific country and specified columns, but when you're doing a group by operations, or when it's not equally distributed like this, so there are chances where your performance may go down. Correct? Do you guys agree with me? Right? So to avoid these kind of limitations, how you come up with something called bucketing? How you come up with something called bucketing? How you come up with something called bucketing? So what is bucketing? Something called bucketing. What is bucketing? Okay, before discussing bucketing, I would like to recollect or recap. Do you guys remember something called partitioning? Partition in MapReduce? I'm not talking about Hive partition. I'm talking about MapReduce partition. Do you guys remember?
Yes, sir.
What is that partition? What is a MapReduce
We're
partition?
sending, yeah, we're sending particular uh, like female data or male data into particular files.
It means you are segregating your map output to different reducers. Correct? So what you are doing in there? You have a map 1, map 2, map 3. Three maps are running on some data. Three maps are running on some data. So when they're running on this data, let's assume that gender wise, I want to segregate the data into two different reduces. Different reduces. Correct? I want to process the map output. I want to process this mapper output in two different reduces. So what will happen? This output will go to a shorten shuffle phase, right? Then based on the partition key, whether it has to go to reducer 1 or it has to go to reducer 1, it will be divided. Correct? Yes or no, guys? Based on the your partition key, based on the partition key, whether it has to go reducer 1 or it has to go reducer 2. Correct? So what is that? Partitioning. What is the default partitioning in MapReduce? Hash partitioning. Hash partitioning. Correct? What is the hash partitioning is doing? It will take output of the mapper 1 or mapper 2 or mapper 3, whatever it is. It will take the key. Okay? It will take the key. Let's assume that gender. Okay, gender is my key. If I'm getting male as a key, the value of the key. Okay, I'm getting male. Then so it is a gender, right? Our key type is gender. So what the gender can have? Either male, female. It is a K2. If you guys remember what is K2, it is a K2 and V2. So now the male has to go reducer 1 or reducer 2. How will I decide? Whether the male has to go reducer 1 or reducer 2, how will I decide? I will decide based on the some hashing function. Correct? So now what I will do, male dot male dot male dot hash code will find male dot hash code modulo by how many reducers? Two reducers, right? In this case, let's assume that I got 110 is the hash code of the male, then modulo by 2. Now 110 means the remainder is 0. It means if it is 0, all male will go to reducer 1. Let's assume that I'm getting female. So again the same hash code. I'm just giving an example, guys. So hash code, you are not going to implement anything. The by default it will apply the hash partition. If you want to apply anything, you can apply using your custom partitioning, right? That is called custom partitioning. Okay, so we may not do directly on no hash code on the mails. So whatever the value you are getting, so if you know the value is male and female, you can write your own custom by specifying if condition, if gender equal to male, if gender equal to male, return 1. If gender equal to female, return 0. You can do that. So here I'm showing you an example. Okay, I'm showing an example. Then it will reminder, let's assume that this is 101 modulo by 2 and it will come 1. So what will happen? The female will go to, so what we are doing here, the data we are segregating based on the hash code. What I want to show you here mainly, what we are trying to do here, we are, we are trying to segregate the data based on the specific key into multiple buckets or multiple reducers. Correct? The bucketing also works similarly. In the bucketing is another technique. Bucketing is another technique to segregate your data into fixed number of buckets or fixed number of small parts. Bucket is another technique where you can manage the data into small parts. The small parts are fixed small number of parts. In the dynamic partition, do you have any control to, no, I will get only 2 partition, or I will get only 3 partition? Until it is a static partition, you cannot say that whether it's a 2 partitions or 3 partitions. When it comes to the bucketing, while creating a table itself, I will specify my whole data has to go to 3 buckets, 4 buckets, 10 buckets. How will I specify that? How will I specify that? Based on the bucketed column. The bucketed column. Look at guys here. Are you guys able to follow? Any doubt? Let's say the whole data I'm dividing into small buckets. Small bucket. Okay. Let's assume that I have created 3 buckets. Okay, 4 buckets. Now, how I decide, how will I make sure that the specific data will go here, how specific data will go here in this bucket, in this bucket? So what I need to do, I need to specify my data, I need to specify my data has to be bucketed on which column, on which column, based on which column. Look at here now. Now let's assume that I have something called employee data, which has employee ID, name, salary, age, department. Okay, now I want to divide my whole data in based on the employee ID. So what will happen, while creating a table itself, you will specify my data has to be segregated into 4 buckets, and this is the bucketed column. This is the bucket column. How you are specifying the partition column? The same way we are specifying that this is my bucket column. Now if I specify my bucket column as employee ID, let's assume that. So employee ID can be 101. Let's say P101, P102, P103, P110, whatever it is. Now this is my bucketed employee table. Now this whole data I want to segregate into 4 buckets. Okay, how will I do? So when I specify my bucketed column is this, My bucketed column is this. Employee ID is my bucketed column, right? So while it is loading the data, while it's fetching the data, instead of saying loading, while it's fetching the data, what it will do, it will apply the hash function. Okay, let's assume that your P, your P101 hash code is 101. Modulo by how many buckets? 4 buckets. So what is the reminder here, guys? What is the reminder? Guys, 1. What is the reminder here? 2. Let's assume that this is hash code is 1 or 3. When I 4, 4, like this. When I say 110, 110, the reminder is 520, 522s, right? So reminder is 2. So what is happening here? What is happening here? The data, let's assume that, let's say 120, 120. So if it is 120, so how many 425s? Oh, sorry guys, here I think so I did something. Okay, let's assume that it's getting something like this. It's getting something like this. Now what happened? This data will go into this bucket. 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 So whatever the data you are specifying, it makes sure that 0, 1, 2, 3. 0 it always goes here, 1 is always goes here, 2 is always goes here. It makes sure that the data will be most of the cases almost distributing the equal number of parts. Understand guys what is the bucketing? Any doubt? Aparna, Madhu, Devashish?
No, sir.
Yes, miss.
Yeah, so your data is getting divided into equal number of parts, but it may be almost, it will try to reach almost, okay, try to segregate equally almost. It will, most of the cases it will be very near to the equal. Okay, it is done. So and also we are fixing the number of buckets, right? So there won't be any chance there will be fifth bucket. There won't be any chance there will be fifth bucket. Whatever the data is getting, the data will be distributed into only these 4 buckets. Okay, so what is the advantage doing a bucketing? The advantage is that whichever has the same hash code, they will go to respective buckets. This is employee table. Let's assume that I have one more table called assets table. Asset table. So in that employee ID, asset, what asset he has. Let's assume that. I want to join these 2 tables. And this asset table also bucketed based on the employee ID. This asset table also bucketed based on the employee ID. So now in this case, it is easy to join these 2 tables because the data is properly segregated into buckets. I know what this bucket has, 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 right? Guys, bucket is nothing but a file in a respective table. Partition is a directory, under that you will be having a file. But bucketing is it's not creating multiple folders. It is creating a 4 files under single table. Let's assume that I created a bucketed table of employee. When I'm loading the data into employee, it will create a 4 files. Each bucket is a 1 file. Each bucket is represent 1 file. In this case, when you launch a MapReduce job to join, when you launch a MapReduce join, so most of the cases one mapper will be processed by one bucket, and each bucket is nothing but one reducer. Number of buckets equal to number of reducers, automatically it will be launched. Number of buckets equal to number of reducers, you no need to specify how many reducers. So you specify your high level configuration, how many reducers are there even in your environment. If you specify 4 buckets, it means this table is required 4 reducers. So automatically it will be segregated into 4 reducers. So the joins is very easy to join on the same bucketed. Suppose this table also bucketed in the same column, this table also bucketed in the same column. You can easily join the table data by specifying, because your map knows it. So you can also sort the data. You can also sort the data while loading. You can also sort the data. So it is your joining is making easy. Okay. Another important part, another important thing is table sampling. I want to get a sample part of the data. I don't want to get the whole data to test my logic, or to test whether it's working fine or not. I don't need to get the whole data for the testing purpose. I can take a portion of the data, part of the data. I can do a testing, I can do a sampling on bucketed table very efficiently. Very efficient sampling, right? Suppose if you want to get the sample data from your Hive tables, what you will do, guys? Let's say I have, if you see, the stock table has a 5,000 rows, correct? The stock table has a 5,000 rows. You want to get the 10 rows, or you want to get the 20 rows. What you will do? What we will do?
Limit. Yes.
Very good, come, very good. So is that limit is making sure that, so the limit will get to the portion of the data, correct?
Yeah.
The portion of the data can be first portion of the data. If it is a descending order, it can be last portion of the data. Always it will come the first portion of the data, whether you're ascending order, descending order, correct? First 10
Yes.
records on it will give you. But I don't want like that. I don't want like that. So let's assume that my data has been distributed across the multiple partitions, and now I want to do something called some sampling. So I want to fetch some data from this, some data from this, some data from this, or I want to get complete this bucket. I want to do sampling on completely this bucket. I want to do sampling on first bucket. I want to do sampling on second bucket. I mean, I'm getting the, see, instead of getting same type of data, I'm getting the different kind of data, right? If you say limit, only always it will come first 10 records. Maybe your first 10 records belong to only India. Maybe your first 10 records belong to only India, correct? But I don't want like that. I want a mix of all countries, because I want test my logic. In that case, sampling is very easy to do in a bucketing table compared to non-bucketed table. Okay, let's see how we'll write a code for it. For doing a bucketing, to do a bucketing, we have something called cluster by class. How we have a partition by in the partition table, in the partition Hive partitions, we have the same way clustered by. There is something called clustered by. So that clustered by class will decide how will you divide, on which column you divide, what is your bucketed column, and how many buckets you want, so guys, bucketing is not a replacement of partitioning. Try to remember, guys, bucketing is also another mechanism of segregating your data into small parts for the better performance, right? So it is not replacement of your partitioning, or it is not no what to say, better than your partitioning. Both have their own advantages. Both can work together. Both can work together. You can create a bucketing on partition table. You can create a bucketing on non-partitioning table. You can do that. So let's look have a look how we will write that. How we will write the bucketing code. Look at, guys, here. I'm creating a stock table. A stock table is already there. Okay, you know that the stock table is already there. Now your stock table is already there, right? So you can check it here. I'm not going to create the stock table again because stock table is already there. You have a stock table already. Stock underscore stage. Stock underscore stage. We have already stock table. Right. So from the stock stage table, okay, let me get in there. Otherwise, don't get confused. Then let me get from the stock table itself. So how many places it is there? No, not this one. Not this one. I forgot the location. That's why I'm just load command. Actually, I want the load command for the stock because I forgot the location of where my stock data is there. Oh, yeah, I know it. 1 second. Let me do that in this case. First, we should know where the data is there. First, we need to understand the data first. Sorry, guys. Not this one. That's what I'll be keep forgetting. Hive input or something. Yeah, in that partition, in that. Yeah, this is the one. This is the one. Okay, now this is my data. This is my data. From this data, I want to do bucketing and also partition. Both can be done in this. This data contains my symbol tick. It is called tick. Date, open price, high price, low price, closed price, and volume. These are my columns. Right now, I need to load the data in it. Okay, let's look at that. So partition underscore bucket, right? Date underscore. I think I'm just looking for the path. Yeah, this is the path I'm looking for. Otherwise, I need to, again redesign the, everything. Okay, this is the one. Okay, so let's go ahead and execute these two lines. But it is stock and it is stock temp. So I will use this as a stock temp. Okay, I'll also say that is a stock temp. So number of lines are equal or not, just check. Symbol, open stock date, open price, high price, low price, close price, close price, and number of volume of it. Correct. This is as similar as normal, guys. We're just creating some table. Okay, so is there some already stock temp is there? Okay, stock temp for bucketing. Stock temp for bucketing. I don't want to make you confused. That's why I'm taking proper name for each and every bucket. If I use the same table, you may get confused. Okay, okay. Table is created. Now I'm loading the data in it. Guys, I loaded the data. No, I didn't insert the data. I load the data, MapReduce is not launched. If I insert the data, the MapReduce job is launching. If you remember, yesterday we have seen this. Correct? Now, I'm creating a bucketing table. I'm creating a bucketed which is without a partition. Look at guys, my query, very simple. Stock bucket and all your symbol, You can take your date, you can take your open price, you can take your high price, you can take your low price and close and volume, everything. What, Ravi, you are taking everything? Yes, it is not like a partition. In the partition, your partition column should not have, the partition column should not be part of table definition, correct? But your bucketed column can be part of the part of the table definition. It has to be part of the table definition. It has to be part of the table definition. Why? Why? Because in the partitioning, you are explicitly creating high level one more directory where is you specifying the column name and value. It means you are ideally creating one column in the table. But in the bucketing, we are not creating a column. We are creating a separate file based on the value or bucketed based on the bucketed column. Okay, and it will calculate the hash functionality on top of it, and based on the hash it is creating. So now I want to create my bucket based on the symbol. I can do it. I'm going to create I'm going to create bucketing based on the symbol. Let's look at, I think stock bucket is not available in this. Stock underscore bucket is not there. We didn't execute till yet. Okay, now let's look at, I'm going to execute. I'm as similar as your code only, guys. See here, let me explain the syntax of the bucketing. You're clustered by symbol into how many buckets. So let's say instead of that, I'll say 16 buckets. 16 buckets. You can say into these many buckets. You can store as a text file. You can store as any other files, and also you can also specify a sorted by. You can also do a sorting. You can also do a sorting. Okay, whatever the column you like to sort, you can also specify the sort here. Okay, so there are the open options for this. You can use the options. You can also use the partition thing we'll see in the next example. Table is created successfully. Now, as similar as your partition, we cannot load the data into the bucketed table. What, Ravi, we have loaded some data into partition? No. Yes, in the partition you have something called static partition, where when you know the data, this data has to go this particular date. When you know the data, you can do that. We can do that. But when your data it is coming as a whole data in a single file, we will do insert command. Same way we have to do insert command here. Very simple, guys. If I load data into this table, what will happen? It will just like a copy paste, dumping the data in it. Who will calculate the hash code functionality? Who will do the hash code functionality? Someone has to do hash code functional. MapReduce has to launch, to do the hash functionality. For that, we will do insert. That is the reason your bucketing will not allow you to load the data into bucketed table. You have to just fetch from other table. You have to fetch from other table. So that's why I'm fetching from, it should not be a stock, it should be this. Now look at, insert into your whichever the table you want to insert, and select star from other staging table. Very simple query. If you see now, it will start launching MapReduce job. And closely observe your logs, guys. Here, please observe the logs. Number of reduced tasks determined by compile time. How many? 16. Why 16? How many buckets? 16 buckets. So your number of buckets is equivalent to number of reducers. If you define those many buckets, this will launch those many reducers. See here, how many number of mappers? One mapper, 16 buckets. Okay, because we have very less data. That's the reason one mapper only. Bucket is, but your reducers are 16 reducers. Your map is completed 100%. Your map is completed 100%. Now we are executing a reducer job. So it is it will take quite more time because it has to calculate the hash function. It has to calculate the hash functionality. So that's why it is taking, now the map is just fetching. So map is not going to do anything. So it has to apply the hash functionality on top of the mapper output. So on top of the mapper output, right, on each column. So that's why your reducer is taking some time. Mapper is just fetch the data. Map output is emitted. On map output, the hash functionality has to execute. That's why it is taking quite amount of time. Okay, by the time you just go and look at the data, the structure of the folders, how the tables has been created in HDFS. Okay, system is a little slow because all the resources are occupied. Are you guys going, are you guys able to follow, guys, or it is confused? Aparna, Madhu?
Yes, sir.
I'm very able to understand.
Right, you guys are able to, okay. So there is a stock temp for bucket. This is what I have created, stock temp for bucket, and I have loaded the data in it. I have loaded the data in it, in the stock. Okay, I have almost 5,000 records are there in this. Okay, now go back to this. Now what I'm doing, now I'm creating bucket, stock underscore bucket. Now I'm creating stock underscore bucket. When I click on the stock underscore bucket, actually the still in under process. That's why I was saying here, temporary thing. Still under process. It's not completed. Still under process. Okay. Now it is done. Now it is done. So now you look at here, guys. How many files has been created? All our files, not the directories. How many files has been created? 0 to 15. 0 to 15. Correct? Yes or no? 0 to 15 files has been created. If you see the size, guys, is the size is closely equivalent? The size of the data, size of the each bucket closely equivalent? Yes or no?
Yes, sir.
If it is in partitioning, do you have any guarantee like that? No, right? So here equally distributing. So when it's equally distributed, I can also have a properly number of mappers. They can also start processing properly. And if you go ahead and look at the data in this file, all are started with the uh, okay, this is some special character, don't worry about the special character. And see, is this a same data, or it is just hashed data, and each column it found the hash functionality. Okay, so these are all falls under the specific hash function. And when you go and look at other table, these are all falls under some specific hash, and this is comes under this bucket, right? So you can go ahead and look at the all the buckets. This is we have created without partitioning. We didn't create any partition here. Directly I have one table. The table is nothing but one directory here, and in that directly I have some small files. All are files 0 to 15 because my total number of buckets are 15 buckets. Okay, now 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 so what we will do, we will try to create with the bucketing. With the bucket we'll create. So guys, when you are creating with the with the partition, when you're going to create with the partition, so we are going to create dynamic partition, no? So if it is a dynamic partition, I should tell to my environment saying that I'm going to use a non-strict mode. So I'm going to tell to my environment saying that it is a non-strict mode, because I'm by setting the value. I can set it in hivesite.xml itself. I don't need to set every time, but I'm setting. Okay, for sake of the process. So here, let me explain here once. create table name, again same temporary table, again same guys, same how I created for the temporary table, same temporary table, same. Okay, and loaded the data, and stock bucket and partition, I'm creating it into 32 buckets, and formatted this. I'm inserting overriding in from a bucket table from a stock table in this my case, not the stock table, it is for temp for bucket table, temp for bucket table. Because I mean I already created, I don't need to create the same thing again. So now I'm going to execute with the partition. If you guys look at the syntax, partition by date, partition by date I have taken, and clustered by symbol I have taken into 32 buckets. You can take 32 or you can take 16. So I'm happy with the 16 buckets. I'm going to create like this. I'm going to execute both the statements. So now the table is created. Now I'm going to write into partitioned. Now I'm going to write into partitioned. Okay, partitioned bucket. So let's look at it. So it will also take quite a long time. So because it has to, now it has to divide the partitions, and inside each partition it has to divide the buckets. Okay, so let's look at, let's take a time, because map job is nothing here, just fetching the data. Map job is nothing here, just fetching the data. The more into reduce side, because it has to find the hash functionality. Hey, hi Anisha, Ganesh, Harika, and Kishore, Raghu. Please stay back. So I'm about to complete this. I don't want to drop in middle, so that's why I'm continuing. Please stay back.
So one doubt I had.
Yeah, go ahead.
So is it not possible to change the bucketing type? Like we are using hash code, you said, right?
Hmm.
Like we can't use our own or some other type of.
No, by default it is hash only. I think we cannot change the functionality of the bucketing. How it has to divide, we cannot change it. As per my knowledge, we cannot change. So I will come back on this. It's a very nice question. We will try. Like you're talking how we have a custom partitioning in MapReduce, right? So, yeah. So I will check it. I'll check and come back on this.
Okay,
And also we can do a bucketing on only one column. We cannot do multiple columns.
okay,
The bucketing can be done on the same one column only. We cannot do multiple columns. Yeah, it's done. Now go back to your data and look at. Go back to your data and look at. So what is the other table we have created? Uh, stock bucket underscore partition. Stock underscore bucket underscore partition. Now here, what is my partition column? Date. What is my partition column? Date. I have a date column. See here, first the partition has been created, and go inside, and your partition has multiple buckets, 16 buckets. See here, 0 to 15. If you observe here closely equivalent parts, equivalent small files. Yes or no? right? So if I assume this date, it is as a size of 100 KB, my other one may be less. See here, all are in bytes only. So 0 bytes, here 0 bytes, here 0 bytes. There may be some buckets, there may be some buckets who come with no data, no data. So it is also can possible. I think we can avoid these things, like how we have in a MapReduce something called lazy output format. I think we can also follow the same thing here, but I will look into that. So I really didn't get look into that, so how it will work. Okay, so this is about bucketing, guys. So we will continue the bucketing tomorrow as well. Tomorrow we will have a class. Okay, tomorrow we'll have a class and we will continue tomorrow about the bucketing. Okay, so there is one more thing has to cover in the bucketing, that is called sampling. So the sampling will cover tomorrow. We'll cover sampling tomorrow. What is the sampling, how it is different from the limit. These two we will be covering tomorrow. Yeah, any doubts, Aparna, Debashish, Madhu, Srini,
No, sir.
Sunil?
No.
It's clear, right? Any doubt? Madhu?
No, Veera.
Okay.